In this presentation, we will talk about the assessment of ecosystem services. We will describe the purpose of an assessment of ecosystem services and review some of the tools used for this type of assessment. Let's review some key concepts first. Beneficiaries are the people or organizations that use ecosystem services. Dependency is the reliance of individuals, communities, or organizations on particular ecosystem services. The supply is how much of a service an ecosystem can produce and can be taken from it. The demand is how much is being used by people. The impacts are the negative effects that projects, plans, policies, programs, or laws can have on the capacity of ecosystems to provide services or on the quality of the service for the beneficiary. The benefits are those positive effects of the interventions on the capacity of ecosystems to keep producing services. An ecosystem services assessment is an ecosystem-based approach to environmental and social impact assessment to determine the impacts and benefits that human interventions can have on the environment and the services that people rely on. It follows the basic steps of the Environmental Impact Assessment Process, or EIA. In summary, here is identifying project activities that might affect the environment or the ecosystems, identify the impacts that this can have on ecosystem services or on those groups of individuals that depend on them, and identify mitigations or measures to reduce the impacts on ecosystems. So, impact assessment will consider how project activities might affect the capacity of ecosystems to provide specific services and what measures should be implemented to mitigate the predicted impacts. In the case of Eflows, the focus could be on understanding the dependencies of those beneficiaries on the flow-dependent ecosystems and assess how the interventions will affect the supply or demand of services. Then this information will be used to create mitigations aimed to maintain Eflows. The assessment of ecosystem services requires a system approach to understand the interactions among different societal groups and the environment. These together define the socio-ecological system. Understanding the processes that determine ecosystem dynamics and what is the supply of services should be complemented with the understanding of how people uses and values these services individually and as bundles or groups of services. However, different groups of people perceive and use these services in different ways. And how they use them influences the ability of other users to benefit from the same or other services. If the consequences are negative, this might lead to conflicts. An assessment of ecosystem services can help improve policies and management practices and contribute to regulate the use of resources in a way that considers the well-being of all societal groups and the integrity of the ecosystems. The purpose of ecosystem services assessment is to determine how significant the impacts of a human intervention are on the supply or demand of ecosystem services and on the well-being of the beneficiaries. The overall significance of an impact is a function of the magnitude of the change in the supply and demand of ecosystem services and the effect of that change on the well-being of the affected people. The assessment will consider different criteria. For example, how much a group of people depends on a service, What is the capacity and appropriateness of replacing a service of a good with another? How a change on the environment and in the ecosystem could alleviate or increase poverty and vulnerability of specific groups, or how this change could facilitate or obstruct the access of a group of people to a service or good. As in other forms of environmental and social impact assessment, the assessment of ecosystem services must adhere to guiding principles. Before we have talked about the principles of participation and inclusion, among others. The precautionary principle is another, and it is very important because the lack of knowledge about an ecosystem or a lack of scientific evidence to decide if an effect will be significant should not prevent action to avoid impacts on ecosystem services, especially those that could not be reversed or compensated. This means that if there is not enough information to decide if an impact will be significant, decision makers should assume that it is going to be significant and act accordingly. Significant impacts might be, for example, changes that will bring ecosystems near system thresholds or critical points of transition from which they could not recover. In other words, changes that will affect the resilience of ecosystems. Significant impacts occur when value components will be affected. In the case of Eflows, that could include modifying flow regimes outside of their natural range of variation required by sensitive, rare, unique, or endangered components, being them living or non-living. Impacts are also considered significant if critical ecosystems and social processes could be modified, or the changes will happen on biodiversity for which there are not proven restoration techniques. Considering the variability of water and sediment flow regimes and aiming to allocate e-flows, considering a buffer to give room for uncertainty in data and to accommodate future needs is a way to apply the precautionary principle to maintain water-related ecosystem services. Impact assessment can be applied at different levels to determine effects on flows and their related ecosystem services. At project level, environmental and social impact assessment, EIA, should be used to determine how the activities during the construction, operation, and closure of a project could alter flows, affect ecosystem services, and people's well-being. At other levels of decision-making, strategic environmental assessment or sustainability appraisal can be used to determine how the direct, indirect, and cumulative effects of regional plans will affect water bodies and ecosystem services, or how the actions or strategies outlined in policies, programs, or laws could directly or indirectly modify human activities in a way that would affect the integrity of ecosystems and the provision of services. For example, a national policy to reduce emissions resulting from the production of electricity with fossil fuels might aim to increase hydropower plants to increase the use of renewable resources. Depending on the type of hydropower plant, this increase could affect river systems and the related biodiversity in different ways, resulting in changes in the provision of ecosystem services. The United Nations Environmental Programme commissioned a guide to include ecosystem services in strategic environmental assessment. This assessment is more appropriate to assess impacts on environmental flows and the related ecosystem services because usually it is applied to regional or sectoral plans or other large-scale interventions. Although e-flows can be considered in environmental and social impact assessments for a project, for example, a dam, a regional approach will allow the assessment of different alternatives to reduce the impacts at regional level. Strategic environmental assessment should consider how different projects or activities in a region can cumulatively affect ecosystem services, and then identify alternatives to reduce the impacts in the region and not just in the area that would be affected by a single project. The diagram illustrates that this is an iterative process, and the United Nations considers 4 steps. The first one is to establish the context for ecosystem services and the assessment. This includes the social, environmental, and economic context, and might include and should include mapping ecosystem services and the beneficiaries. It's important also to consider the links with other laws or regulations or other actions. The second step is to determine and assess the priority that different ecosystem services might have. It's important to prioritize because it might not be possible to try to consider all the services. And stakeholder input is very important for this prioritization. The next step is to identify alternatives and assess the impacts on ecosystem services that each alternative could have. The purpose could be to define which is the best alternative that provide more services with less impacts for different groups. Then, the final step is to follow up on the measures that have been designed to maintain ecosystem services. This includes monitoring to know how the mitigations or actions are working and managing the supply and demand of the ecosystem services. The assessment of ecosystem services does not need to be quantitative to be useful. Often what is important is that all involved parties understand how the changes induced by an intervention will affect ecosystem services and people's well-being. It is important to consider that the scale of the assessment might influence the results. A regional focus might overlook impacts or services at local level, so it's important to consider different levels. The assessment of Eflows should leave margin to avoid reaching thresholds that could push aquatic systems beyond recovery in case of extreme conditions. The table in this slide summarizes 12 points to keep in mind for the assessment. Pause the video and take time to reflect on them. Let's talk now about different tools that are available on the internet and are free and that can be used to assess ecosystem services. These tools are both qualitative and quantitative, and also consider effects on biodiversity. We will cover 4 different tools. ValueS is a project of the German government to develop a simple and qualitative tool for stakeholders to engage in discussion about how planning decisions might affect ecosystem services and human well-being. It is a tool for participatory assessment that promotes collaboration to find alternatives that will benefit most or all of the beneficiaries. The illustration indicates the 6 steps of the process. Data, if available, can be used to inform stakeholders, authorities, proponents, communities, NGOs, so they can estimate in a better way the trade-offs that different decisions might impose. The steps in the guide should be adapted to the local context. The first step is to define the scope, so establishing the objectives for the assessment and designing the process for engaging stakeholders. The second step is screening and prioritizing to define what ecosystem services are relevant to the development that is being discussed and to the beneficiaries. The focus is to identify risks and opportunities. The next step is to identify the conditions, trends, and trade-offs that might occur among different ecosystem services when different options are explained. So this considers that there might be different alternatives to achieve the same end, and each one of them might have different benefits and impacts. The next step the Global Oil and Gas Industry Association for Environmental and Social Issues, or IPECA, has also created a guide for assessing the impacts of oil and gas activities on ecosystem services. This guide focuses on minimizing impacts on ecosystem services to reduce business risks. The guide contains predefined impacts on ecosystem services based on common activities related to oil and gas operations. And the guide explains how these impacts might result in business risks and suggests actions to mitigate the impacts to avoid those risks. The World Resources Institute has produced a simple guide and assessment tool to identify impacts of projects on ecosystem services. The tool is based on a spreadsheet and is free to download. It provides a qualitative assessment that can be used as a first step for a quantitative analysis. To determine priority ecosystem services, the tool uses a list based on the Millennium Ecosystem Assessment. It analyzes project dependencies on ecosystem services and impacts of business operations on ecosystem services that benefit the stakeholders. It divides the assessment in three main steps. Scoping, to determine the purpose and detail of the assessment. Impact assessment and analysis, consisting on identifying the priority ecosystem services, defining the trends in supply and demand, estimating impacts based on the expected changes, and the final step is mitigation, to propose measures to reduce the significance of the impacts. Stanford University, through its Natural Capital project, has been developing different models for integrated evaluation of ecosystem services and trade-offs, called INVEST. These models can be used independently to quantify specific ecosystem services, or can be used together for regional multi-objective assessment. The models might not be easy to use if data are not available. Many of them require the use of GIS to process the data and to generate maps. Here you can see a list of models that have been developed. Models of interest for Eflows include reservoir hydropower production or water yield, sediment retention, and coastal vulnerability. The final output maps of INVEST models for hydropower and valuation show values for energy production and hydropower revenue over the lifetime of the reservoir, this resulting from the water yield in a basin. The models can estimate reductions in energy to allow for other users, including maintaining environmental flows downstream. We are at the end of this presentation, and we have some key messages that we would like you to remember. Ecosystem Services Assessment is a tool to identify the impacts on ecosystem services and the groups of people that benefit from them. Environmental and social impact assessment and strategic environmental assessment can include ecosystem services or focus specifically on how projects, policies, programs, plans, or laws could directly or indirectly affect e-flows and their related ecosystem services. The purpose of an assessment is to identify development alternatives that will minimize the negative impacts and then propose mitigations that will ensure the maintenance of e-flows to protect the well-being of those that benefit from ecosystem services.